So let's look at what forward selection and backward elimination do for the Hout model. We know that there are two interactions in the Hout model that we probably don't want because they only depend on two observations. But we will include them here now to see what happens with the model selection procedure. Maybe they get rid of them. Here is a clicker question for you. We have the full Hout model here with the square term and the two interactions and the significant e-vote. And so the question for you is, which variable is removed second for backward elimination here? Okay, so I'll let you to answer that question, and I'm moving on. And I'm running the backward elimination here using 10% as my probability to exit. And so what I see is one of the interactions is removed. Income again is removed. But e-vote remains significant. The square term is still there and the other interaction is still there. Okay. All right, so let's see what happens if I go stepward regression. I have here 10% and 15%, so I'm being very permissive. I'm allowing more variables than I would be if I went 5%. So we're adding income again as the first variable, right? So there's a difference right there. We're not adding anything, any of the interactions or the square term. So I have a relatively normal looking model. And it so happens that I never ever remove any variable, otherwise it would show here. And that means that the stepwise regression is identical to the forward regression. That is often the case, but not always. So, yeah. Well, so what does this all mean? It means that the model selection on a bad model with the two interactions does not create a good model. And, or not necessarily a good model, right? So adding the interaction is not a good idea. We just did that to see how that works with the model selection. That is the end of this video.